Do you know river couplers are more preferred than the conventional lap splices as well as welding? Also, you can save at least more than rupees 8,500 per metric ton. Add to that, you will have no limitation of rebars joint in one section, no OD for lap zone or confined zone, minimizes bar congestion, reduces RCC member sections, more floor space. It reduces concrete by cement ratio and improves concrete quality by having bigger space between bars. It reduces slab to slab cycle time and also reduces project duration. It's highly cost effective and economical, more earthquake resistant construction. But the interesting fact is just seeing the benefits. You can't replace lap splices by rebar coupler blindly. There is quite a type of couplers are available in the market, you should know. All these types, their areas of applications, pros and cons, and benefit cost ratio. Also, each type has further two grades, that is type 1 and type 2. Each coupler should pass at least 4 tests prior using. Also check the coupler material grade, whether it is EN8D or other. Hi friends, if you are an architect or an engineer or any professional attached to the construction or real estate industry, then to know the secrets and benefits, you can't afford to miss this informative video anymore. Stay tuned and watch till the end and unlock the hidden potentiality. It's a compilation of useful knowledge as available, blended with practical exposures and experiences earned from the project sites. Hello friends, myself Avijit Datta. You are watching our YouTube channel Smart Engineers. As you know, in Smart Engineers, our motto is to discuss about the subject matter which are not covered adequately in our college course curriculum, but there is a huge demand or requirement in practical or professional field or in industry. Let's try to bridge this huge gap between the academia and industry and develop our country. Before we proceed further, request you all to subscribe our this informative channel and press bell icon for immediate all future notification and updation. Friends, if you haven't watched our earlier two career advancement videos, that is how to earn IGBC AP certification in next 2 weeks, that too in first attempt, and how to become IBBI registered valuer and earn huge. Please watch them and get hugely benefited. Also, check out our practical research work on pre-stress concrete and how to do APDM flooring, a foolproof solution for building waterproofing, smart engineering approach, basement or underground structure waterproofing, where and how to place construction joints in concrete, second pile shoring system, how to execute and manage deep excavation. You will get all these informative videos in our YouTube channel. Please go through and upgrade yourself. Use river coupler for huge benefits in your project. Disclaimer: this video is prepared for educational purpose only. The intent is to bridge the gap between academia and industry. While compiling the subject matter, a few images and videos were taken from the internet for appropriate presentation and fair use. Neither any copyright claimed on those nor any copyright infringement intended. As it is an educational presentation, it shall not be used for any legal or other use. Preambles. Construction practices in the building of concrete structures have focused on the use of steel reinforcement to transfer tension and shear forces. Lap splicing has become the traditional method of connecting the steel reinforcing bars. Splicing the reinforcement bars by laps or welding have various imperfections such as low quality welds, inadequate length of laps, failure in joints, increase in labor cost, etc. Permanent study was focused on the use and applicability of reinforcement couplers, especially threaded ones, as an alternative to lap splices. A case study of an under construction site was taken where couplers were used. An estimation of the cost of couplers was done. Alternatively, the cost of steel was also determined for providing lap splices in the column. A comparison has done to show the difference of cost in lapping and use of couplers. It was found that the use of reinforcement couplers significantly reduces the consumption of both construction time and reinforcing steel. It also increases the overall reliability of reinforcement splices. The reinforcement couplers not only provide strength to the joints, but they are also an economic means of construction of two bars. Introduction. Lapping welding coupler. There are three basic ways to splice the bars: lap splices, mechanical connection, and welded splices. Lapped joints are not always an appropriate means of connecting reinforcing bars. The use of laps can be time consuming in terms of design and installation and can lead to greater congestion within the concrete because of the increased amount of rebar used. It also decreases the overall reliability of reinforcement splices. Of the three, lap splicing is the most common and usually the least expensive. But the coupler system is available in several styles to meet virtually any application. The applications include standard bar-to-bar connections, pre-caging applications, hooked bar applications, closure ports, precast connections, rebar terminations, and anchorages. Transition splices, segmental construction, and connections to structural steel. Most popular splicing systems are interlocked, quick wedge, speed sleeve, terminator, lock, form sever, tapered thread splices, and CAD weld splices. More and more engineers are specifying mechanical reinforcement connections over lap splices. They have found that mechanical connections afford a reliability and consistency that can't be found with lap splicing. Lap splices depend upon concrete for strength, so they lack structural integrity and continuity in construction. Mechanical splicing assures the maintaining of the continuity of the load path in the reinforcement, independent of the condition of concrete. Mechanical splices deliver higher performance than a typical lap splice. Generally, it is 125% to 150% of the reinforcement bar. Mechanical splices can wear and can deform more than a lap splice before failure occurs. Lap splicing, which requires the developing of two parallel bars, has long been accepted as an effective economical splicing method. Lap splices usually are in contact but in flexural members. The bars can be separated by as much as 6 inches. Bond between steel and concrete transfers the load in one bar to the concrete and then from the concrete to the other, continuing rebar. This transfer of load is influenced by the deformation or ribs on the rebar. In projects with small bar sizes such as of number 6 or number 8, relatively low yield stress in steel and building heights of 15 stories or less, lap splices have performed well over the long run. Structural concrete building frames are being pushed to 100 stories and more. Current design practice for structural framing uses bar sizes from number 8 to number 11 with yield of 60 to 75 ksi and concrete strength of 8,000 to 12,000 psi are accepted by code and increasingly used. Use of higher strength concretes allows for shorter lap lengths. However, these concretes are more susceptible to splitting failures, raising questions about the adequacy and reliability of lap splices. General information: coupler and coupler sleeve. Let's study the definition given by ASI 116 about mechanical splices. A mechanical splice is typically comprised of either a coupler or a coupler sleeve, as noted above. A coupler is a threaded device for jointing reinforcing bar for the purpose of providing transfer of either axial compression or axial tension or both from one bar to the another. A coupling sleeve is a non-threaded device for jointing reinforcing bars for the purpose of providing transfer of either axial compression or axial tension or both from one bar to the other. General information. Now it's about tension and compression coupler. Most mechanical splice systems are designed to meet the requirements of governing codes. Mechanical splices that develop a code prescribed strength in tension and compression are often referred to as a full mechanical splice. However, there are products on the market that are compression only splices. Please refer CRSI for further detail. This presentation has taken reference from IS 16172 and IBC 2012 along with ACI 318 and respected ASTM codes. Why are mechanical splices used? There are a variety of reasons mechanical splices are used in reinforced concrete construction today. Some of them are as follows. Congestion mitigation, required by design, improve structural integrity, mitigate formwork damage, job site safety, job site safety, continued. Now let's find the comparison between lap and mechanical splicing systems. The important considerations are development, process, dependence on concrete, rebar consumption, rebar limitation, congestion, column dimension, floor area, cost factor, indirect cost. Now, please go through few benefits of mechanical couplers. Few disadvantages of mechanical couplers. Code of practices of few developed countries. Material and methodology. The research work was divided into different headings as structural analysis, manufacturing and specifications, estimations and comparison made between lab splices and mechanical splices. Now, the structural analysis. Manufacturing and specifications. Material and methodology continues. Generally, couplers are manufactured from mild steel, but in some cases, alloys of different materials can also be used. The material should be such that couplers meet the minimum strength requirements, that is 125% of yield strength of rebar. The manufacturing of couplers includes different basic steps as cutting, boring, threading, finishing, etc. The positional coupler comprises two components, a male section and a female section. The couplers are installed using four steps. How does the performance of a mechanical splice compare to the performance of a lap splice? A commonly available type 1 and type 2 mechanical splice products outperform a lap splice connections in terms of stress transfer. Unlike lap splices, mechanical splices do not depend on the surrounding concrete to transfer load, making them the generally preferred option for designs that anticipate loads greater than the bar yield strength. What is a type 1 and a type 2 mechanical splice? A type 1 mechanical splice is a full mechanical splice that develops in tension or compression as required, at least 1.25 times of Fy of the bar, where Fy is the specified yield strength of the reinforcing bar. In case of type 2, it is similar to type 1, plus it also develops the specified tensile strength of the reinforcing bar, which is more than the yield strength. When to use a type 1 or a type 2 mechanical splice? Please refer ASI 318 code section 21.1.6.2 for earthquake resistant structures. A case study on couplers. A case study was carried out at one of our construction project, name withheld for confidentiality, extended over 40 acres. The project has a mix of duplex and simplex apartments with a 2, 3 and 4 BHK flats, in areas ranging from 1120 square feet to 2300 square feet. This was a case study of an under construction site where couplers were used in place of lap splices, showing the economic advantage of couplers on the normal lap splices. Please go through in detail. You will understand the implication of mechanical splices over lap splices. Indicative pricing of rebar couplers for your reference and further use. Now it is indicative pricing for threading of rebar couplers. Terms and conditions. Benefit of using coupler overlapping. Cost savings. As you can see, we could save up to rupees 8,520 per metric ton by using mechanical coupler in place of conventional lapping of reinforcement bars. Also, please note that in general, rebar works constitutes approximately 15% value in a typical construction project. Out of that savings of at the rate of rupees 8,520 per metric ton is equitable to approximately 2% of the job value, which is quite considerable and shall be contemplated seriously for each and every projects. Schematics of rebar couplers. Area of applications. Here furnished area of application along with schematic diagram and major benefits. Please go through in detail. Types of rebar couplers. Types of rebar couplers. Continued. Depending upon the requirement and area of uses, there are few types of rebar couplers available in the market. Number one, threaded coupler and non-threaded coupler. Further, the threaded coupler can be subdivided into roll thread rebar coupler and cold forged rebar coupler. Likewise, non-threaded couplers can be subdivided into crimping rebar coupler and MBT rebar coupler. Now we will discuss each type of couplers in bit details. Types of rebar couplers continues. Here it is a schematic representation of various kinds of rebar couplers for your reference and easy understanding. Roll thread rebar couplers. Rebar parallel coupler. Tapered thread rebar coupler. Cold forged rebar coupler. Now it is crimping rebar coupler. MBT or mechanical bolted rebar coupler. Where to use MBT type rebar coupler? Rebar coupler size charts. For threaded coupler, depending upon the size of the TMT bar, the TMT rebar coupler sizes comes in same such as 16, 18, 20, 22, 25, 28, 32, 36, 40 mm and so on. Testing and certificates. The coupler in reinforcement is progressed by different rebar coupler testing. Here are the list of tests of the coupler is as follows. Every coupler should pass at least following 4 tests. There is tensile test, chemical test, fatigue test and slip test. Testing and certificates continues. ISO certificate for process quality, testing of coupler materials. Static tensile test report of reinforcement coupler, where you can see that while conducting the static tensile test, the reinforcement bar has failed, but the coupler is in place. Now let's watch the video. Few important references. Rebar couplers can be used in no lap zone of columns and walls. May refer IS 13920 for lap zone or ACI 318. May refer IS 16172 for manufacturing of couplers. Two types of couplers are available, that is type 1 and type 2. Type 1 couplers are bar break type and can be used irrespective of lap zone. Type 1 couplers need UTS as 1.25 FY, where type 2 as 1.06 FY. Welding in place of coupler or lap is not generally preferred as it is changes the physical and chemical properties of the rebar. In case of unavoidable circumstances, welding by low carbon content rod or electrode may refer IS 9417 for welding of cold worked steel bars for reinforced concrete construction. If lap zone not mentioned in vertical structure, then we can use MBT coupler. Also check the coupler material grade EN8D or other. EN-D8 is having less corrosion than TMT steel. If couplers are more corroded in threaded portion, it can be cleaned using any mild rust remover. Also arrange periodical calibration check done for pitch gauge, go no-go gauge used to check metric dia of threaded rebars, go no-go tap gauge used to check internal dia of threaded rebars coupler. May use a threaded gauge for pitch and threaded go no-go for acceptance of coupler. Few reference images. Now a important point to ponder. Uses of rebar couplers in secondary steel. Let us first understand what is secondary steel, then its raw material and process technology. Let's also understand the rib pattern and IS 16172 requirement for rebar couplers. Ductility, size and shape of rebar in the coupler, that is rib size, cracks, split ends. Other uses of mechanical splices. Form dowels. Weldable couplers. Retrofit works. Few frequently asked questions. Does the code require mechanical splices to be staggered? What is the basic reason for staggering mechanical splices? When using mechanical splices in typical segmental concrete pours, it is impractical to stagger. How does the ACI 318 code address this typical application where staggering is not practical? Are mechanical splices manufactured from the same steel as the reinforcement? Are mechanical splices available with a protective coating or made from stainless steel? When mechanically splicing epoxy coated or galvanized bar, is it necessary to remove the coating in the bar region being spliced? Are there mechanical splices on the market when the need arises to connect reinforcing bar of different sizes, that is number 11 to number 8? Is the mechanical splice considered part of the bar when satisfying code prescribed concrete cover requirements? Is a mechanical splice considered part of the bar when satisfying code prescribed bar-to-bar splicing requirements? Does the ACI 318 code restricts either the length or the diameter of mechanical splices? After they are installed, can mechanical splices touch one another? Good news to share. Post observing our presentation on mechanical coupler, many of our associates, contractors and developers already started installing rebar coupler machines at their project sites to get the advantages of it. As you can see, threading being done at site. Not only the vertical reinforcement of columns and walls, they have started using mechanical couplers in the horizontal bars of beam, rafts, and slabs as well. Summary. Due to advancement of technology, nowadays rebar couplers system is preferred over conventional lapping and welding in reinforcement works. Rebar couplers system found more reliable jointing system with higher strength taking capacity. Based on the structural requirement and area of uses, there are quite a numbers of varieties of rebar couplers available in the market. As per the specific requirement, consultant or project engineer should select right type amongst them. Please take care about full mechanical coupler versus others. Also, type 1 and type 2 type coupler. Types of tests and certification of process you should ensure about. By using rebar couplers wisely, we could save approx rupees 8520 per metric ton of steel, equitable to approx 2% of the job value. Also, no limitation, there is maximum 50% of rebar joints in one section, no OD for lap zone or confined zone, minimizes bar congestion, reduced RCC members section, more floor space, reduce concrete or steel ratio, and improve concrete quality by having bigger space between bars, reduce slab to slab cycle time, project duration, highly cost effective and economical, more earthquake resistance construction, and many more. Happy coupling. Thank you. Hope you have enjoyed this informative video and gained knowledge and confidence to use in your next project and develop your career. Further, if you wish to implement the same in your building or project or property and organization and add or earn values, may contact us for further supports. Once again, request you all to subscribe our this informative channel and press bell icon for immediate all future updation and notification. Also share with your friends and contacts you feel will be of their use, because sharing is caring. Thank you all. Hope to see you in next video. Namaskar.